Hello everyone, in this video we will continue this chapter polymers. So I have told you in my previous video I have told you about up to classification of polymers, and now we will discuss few more concepts in detail. So let's get into the topic now. So I have discussed this all. What is so I have discussed these all. What is polymerization and what are the types of polymers, and I have discussed these also classification of polymers, but I didn't discuss these what are the natural polymers and synthetic polymers. So now let's see what are these. So as we know that classification based on source. First classification is based on sources. So these are divided into three types. One is natural polymer and another one is synthetic. Third one is semi-synthetic, right? This we have already learned in that video, right? And let's see now about natural polymer. So these are extracted from natural sources. So here let me tell you few examples. So here these are extracted from natural sources. Natural sources are like animals, you can say that, like animals, or from plants, right? These are naturally extracted polymers. The examples for these are proteins and cellulose also one of the example for this natural polymer. So now let's see about synthetic polymers. So these are man-made polymers. So let's see few examples. Examples for this synthetic polymers are PVC, polyvinyl chloride, right? You have maybe you have heard this PVC pipes, right? So those are man-made polymers, and polythene also synthetic polymer only. So now let's see the semi-synthetic polymers. So these semi-synthetic polymers are derivatives of natural sources. So we have seen here these natural polymers, right? So these semi-synthetic means these are derivatives of natural sources. So the examples for this is generally we can say that examples for these are cellulose derivatives. Cellulose derivatives like cellulose acetate, right? Like we can say that cellulose acetate. And I hope these are clear, right? These are classification based on sources. We have discussed these three in detail, and now let's move to another classification that is based on structure. So these are divided into again three types: linear polymer, branch chain polymer, network or 3D polymer. So now let's see in detail one by one. So now let's talk about linear polymer. These polymers have high melting point and high density. So let's discuss about this linear polymer. These linear polymers are linearly arranged, and these polymers have high melting point and density. So just see, these will be look like. So there will be attractions in the between these due to those attractions generally due to van der Waals forces. So these attractions will be there, and these attractions due to van der Waals forces. And it has high tensile strength also. So now let's see one example. One example for linear polymer is high density polyethylene. High density polyethylene. And you can remember like this: linear polymers are, it has high density and high melting point, right? So you can remember this way. The example for linear polymer is high density polyethylene. So now let's discuss this branch chain polymer. So these polymers has less melting point and tensile strength. So this will be something look like this. So it has, this chain has branches like this, right? And And the example for this branch chain polymer is low density polyethylene. Low density polyethylene. And here there will be less attractions. We can say that there will be less attraction between these two due to branch. So now let's talk about this network or 3D polymer. These polymers are interlinked with each other due to this its packing efficiency also increases. Due to its high packing efficiency, they are hard and brittle. So this will be like due to that interlinkage. So due to that interlinkage, its packing efficiency increases. Due to high packing efficiency, they are hard and brittle. So the example for this polymer is bakelite. Bakelite. And generally this is used in electrical switches. Used in electrical switches. So I'll tell you the monomers for this particular polymers in my next video. So now let's move to another classification that is based on molecular forces. So these are categorized into four. One is elastomers, and the next one fibers, and the third one is thermoplastic polymers, and the fourth one is thermosetting polymers, right? So now first let's talk about elastomers. These elastomers have weakest attractive interactions. Due to this, elasticity will be present. And the example for this is Una S, and we can also, and this is also neoprene, also one of the example for elastomers. And let's talk about fibers. So these polymers contain strong molecular forces of interaction, right? So the example for this is, and one more thing is that these strong forces of interactions is mostly due to hydrogen bonding, due to hydrogen bonding, or we can say dipole-dipole interactions, or due to dipole-dipole interactions. So the example for this is nylon 6,6. So the next one is thermoplastic polymers. So these polymers have force of interactions that is between elastomers and fibers. We have seen in elastomers there will be weakest attractive forces, and we have seen fibers have strong forces of interaction, right? So this is in between elastomers and fibers. At room temperature, these polymers are hard and this can be remolded. Like if you, when we heat them up, these polymers convert to soft material. So now let's see one example. So when we heat them, they convert to soft material. So the example for this particular one is polythene and PVC. So now let's discuss one more polymer, that is thermosetting polymers. These polymers can't be remolded, and when we heat them we can observe cross-linking between them. So if you say this is, if you heat them up, there will be cross-linking like this. These are due to covalent cross-links, we can also due to covalent bonds. So the example for this particular one is bakelite. We have seen this example for what? Network or 3D polymers, right? Same example for this. So now classification based on synthesis. These are two types: addition polymers and condensation polymers. So these are very important topics. So I'll cover this addition polymers in my next video. So bye for now. Till then, keep practicing organic chemistry. We'll meet in my next video.